everyone. Myself Raksha. I am going to do presentation on test of significance of attributes, test for number of success. First, test of significance of attributes as distinguished from variable where quantitative measurement of a phenomenon is possible. In case of attributes, we can only find out the presence or absence of particular characteristics. The sampling of attributes may therefore be regarded as the drawing of samples from a population whose members possess the attributes A or non-A. For example, in the study of attributes literacy, a sample may be taken and people classified as literates and illiterates. With such data, the binomial type of problem may be formed. The selection of an individual on sampling may be called event. The appearance of an attribute A may be taken as success and its non-appearance as failure. Thus, if out of 1,000 people selected for the sample, 100 are found literates and 900 illiterates, we would say that the sample consists of 100 units, out of which 100 are success and 900 failure. The probability of success or P is equals to 100 by 1000 or 0.1, and the probability of failure or Q is equals to 900 by 1000 is equals to 0.9, so that P plus Q is equals to 0.1 plus 0.9 is equals to 1. The various tests of significance of attributes are following three heads. First one, test for number of success. Second one, test for proportion of success. Third one, test for difference between proportion. Here my topic is test for number of successes. The sampling distribution of the number of successes follows a binomial probability distribution. Hence, its standard error is given by the formula. Standard error of number of successes is equals to root NPQ, where n is equals to size of sample, p is equals to probability of success in each trial, q is equals to 1 minus p, that is probability of failure. And now I am going to illustrate one problem of test for number of success. A coin was tossed 400 times and head turned up 216 times. Test of hypothesis that coin is unbiased. Test the hypothesis at 5% level of significance. The solution of this question as under. Let us assume null hypothesis that coin is unbiased. Here H0 is null hypothesis, that is coin is unbiased, and H1 is alternative hypothesis, that is coin is biased. On the basis probability of getting head or tail is equal, that is P is equals to 0.5, Q is equals to 0.5 and N equals to sample size, that is 400. Hence we should expect probability of getting head equals to 200 and tail is also 200. It has to be taken by the half of the sample size. Then difference between observed and expected number of heads is equals to 216 minus 200 equals to 16. 216, that is head turned in coin was tossed 400 times and 200 is probability of getting heads. Then we have to calculate standard error is equals to root NPQ. In that n is equals to 400 and P and Q is equals to 0.5 and 0.5 respectively. Then we should multiply and calculate root of that multiplied amount. Now we get 10, that is standard error. And then we have to calculate the following equation: difference between observed and expected by standard error is equals to 16 by 10 is equals to 1.6. The difference and standard error are already calculated, that is 16, and standard error is 10, that is 16 by 10 is equals to 1.6. The interpretation is that the difference between observed and expected number of heads is less than 1.96 standard error at 5% level of significance. The difference is insignificant, hence our hypothesis is true and null hypothesis H0 is accepted, thus coin is unbiased. At the end, I would conclude my presentation that standard error is used as base for testing a given hypothesis. For example, if the difference between observed and expected mean is more than 1.96 standard error at 5% level of significance, hypothesis will be rejected, and also the mean less than 1.96 standard error, the hypothesis will be accepted. Similarly, at 1% level of significance, if standard error is more than 2.58, level of significance hypothesis will be rejected, and also the standard error is less than 2.58, level of significance hypothesis will be accepted. Thank you.